Hey guys, Hal here. In this video we're going to be looking over one of the new features of SDX 7, and that's the ability to modify the base DLL to change aspects of it before your mod gets compiled. Some of the reasons why you might want to do this include getting access to variables that are restricted in the vanilla DLL, but you want to include in your mod, or include access to your mod. But you can also do some pretty funky things like changing default behaviors and injecting your own code to modify methods. We're going to be covering a couple of these examples in this video. The first one will be changing the access permissions, and then we'll implement a quick mod for expanding the player's backpack size to demonstrate changing how the vanilla classes can be changed. So a little bit of background first. SDX can add this new feature by using a library called mono.cecil or Cecil or whatever. I'll use the names interchangeably from time to time. And what this library does is loads the DLL into memory and gives you access to all the metadata for the DLL, including access permissions and also instructions for the methods, so the actual code that's being executed. And then you can modify these and then save a new DLL with all the modifications in place. I'm not going to be going into that much detail of Cecil. I highly recommend you go and have a quick Google on this on the library. Information can be a little bit difficult to get, but you know, it's well worth spending some time digging into it and seeing what's possible through it, because a lot of funky stuff can be done. So to demonstrate these, sorry if I'm speedrunning this as well. I've tried to do this a couple of times now and it's kept going wrong, so time's getting on. I have to leave soon, so apologies if this is a bit of a speed run, but time is of the essence. So I've set up a demo mod. This is in the, where is it? In the new SDX format included inside the targets for 7 days to die. And what we'll be doing is, well, let's show you inside .peak. There is a variable in the game manager class that I've found while I've been digging around inside the pimp's code. To do that, I'm using a product called .peak. It's a pretty cool tool that allows you to browse all the different classes that come with the game. If you're into modding, I highly recommend just having a play around in here, seeing what you can see, because there's a lot of funky stuff. But anyway, back to it. We've found this variable here with the class type of entity player local, and what this does is gives you access to all the local players' data, such as position, rotation, inventory, equipped item, things like that. And it's quite useful to be able to have a look at these in various mod situations. The only problem with that is that the access level for this variable is set to private, which means that only the game manager class can access it. And what we're going to do here is create a little patcher that turns this from private to public. So if we jump over to the mod folder, I've created a little test mod, so let's have a look at that. And all it does is try and load in this variable and then output to the console the player name, just to prove that it's working. If we try and compile that in SDX, what we should get is an error message saying it can't find it because the access permission is set to private, so the compiler can't can't load the variable. And there we go, we've got the error there. And the error is does not contain a definition for ZR, so yeah, the compiler can't find it. So let's sort that out. To do that, go to the mods folder and create yourself a new folder called patch scripts. And inside patch scripts, I've created a empty class that implements the iPatcher mod interface, which causes the creation of this patch method. Then what SDX does is pass in the module definition, which is loaded from Cecil, and this contains all the information about the base DLL. To speed things up and to get things like IntelliSense, I've included a copy inside the prefab editor solution. So it's just my preferred method of working, but of course you could do all this just through Notepad++ or whatever editor you choose. So let's get started. First of all, what we need to do is get a reference to this game manager class. So we can do that by querying the module variable. We want to have a look at the types collection, and what the types collection is all these classes here that are contained inside the DLL. So because we know the name of the class we want, we can just do a quick types. We can do a quick link query to look for the name of game manager. And what that does is load all the metadata to do with this game manager class. So we'll get options to get into all of the fields and all of the methods and instructions. So let's find our entity player local. Field equals gm.field. We know it's a field because there are no getters or setters, which would make it a property. And again, we know the name, so we can do a quick link query saying ZR. So now what we've got there is something called a field definition, which again includes all the metadata to do with the field item of that class. And to change the access permissions, all we need to do is modify some of the metadata to say is family equals false, field dot is private equals false, and field dot is public equals true. So what we're doing here is just saying that it is not family, or that stands for protected in C#. It's not private, and it is public. To make this a little bit neater and reusable, what could be nice is a little separate method that we can copy in there, and then just call set fields public field. And this way, if there was multiple fields that you wanted to make public, you could just quickly query each and then just pass it over to this method that handles it for you. So that's it for changing access permissions. If we just build this, or if you were doing it through your editor, just save it. What you should notice is, that updates now the build is completed. And if we try compiling again, we should get a proper compilation. There we go. Everything's completed, no errors, happy days. So let's just verify this by looking in Game Manager again. I'm looking for entity player. See, it's set to private because of a bug with .peak. I was going to pimp this out and say it's a brilliant tool and you should definitely get a copy of it, but the last couple of updates have been a step backwards, I feel. So feel free to look around. There are others like IL Spy and Reflector. So let's just restart you. You just have to clear the cache and then reload the assembly, but it never used to do this and is quite annoying. But in the name of thoroughness, let's just reload the assembly. Let's find Game Manager. And now you can see it's decompiling again, so refreshing the cache. And now if we look for Entity Player, you can see it's been turned to public. So that's all well and good. Another handy tip is the variable name here is ZR, but that can change well, it will change on every release the pimps do, so 15.1, 0.2, 0.3, this variable name will change because the code is obfuscated. So a handy little tip is to look by the class type, especially if it's the only class type that's used, or it's only used once in that class, rather than saying looking up on the name. We can have a look for the field type name, and that is entity player local. So that just means that when 15.2 or whichever version comes out, you don't have to update this code. It's far more likely to run first time without a fix needed. So now that's done, we can move on to the second demo. And the second demo is expanding the inventory slot count. So at the minute I think it's set to 32 by default. So let's make ourselves, they're going to be S bytes, old inventory size equals 32, S byte, new inventory size equals 64. So we're going to double the space needed. Well, yeah, let's do a bit of tidying up again. So private void change file field permissions. And we'll just pass in the module definition, and then we can just copy this into there. And now we can just split this up so it's a bit nicer formatted. Private void set backpack size. And again, we'll need the module definition. And we will call it there. So now we're ready to roll with this one. The first thing we're going to need to do is, if we have a look at the bag class, we will see a get slot and a set slot method. So here we go, here's the set slots and here's the get slots, and as you can see we've got a hard-coded value of 32 here. So what we're going to do is we're going to have a look at these methods, and then we're going to have a look at all of the instructions inside the method, look for the value 32 and just change it to our value of 64. If you want to have a look at the IL, which will be handy for you. So if you don't know what IL is, it is the language that your C# code gets compiled to when you hit the compile button, and then the IL is changed to assembly at runtime. So as you can see here, if you don't know much about IL, again, go and Google it. It's something that will be very handy if you want to get into this type of modding. But basically all it is a list of instructions and values. These are the instructions, and well, this particular instruction doesn't have a value that is passed to it. But here we have the instruction for loading an integer onto the stack, and here we're passing the value that we want to load. So it's this instruction here that we want to get our hands on and alter. There's a list of all the IL instructions online. There's quite a few to learn, but what I usually do is just have a look at methods, understand what they're doing from a C# point of view, and then just step through the instructions, and it will start to make sense over time. So anyway, back to it. Let's get our bag class. So we'd query the types. We know the name, so we'll go with bag. Then we need to find the method for get slots. We do that by having a look inside the bag data, querying the methods, and again we know the name, so name equals get slots. So now we have all the metadata and instructions inside this method definition that we've got from the methods collection. And so all we need to do now is get the instructions, and they're inside the body, and it's called instructions. So now we've done that, we can just loop through all the instructions and have a look at the instruction. We want to look for the opcode, which again is this bit here. So we're looking for LDC I4S, and Mono helpfully gives you a collection that you can query. So LDC I4S, there it is. And we might as well be a bit more specific and check the operand, which is the value that is getting passed. And if that is the case, we just update the operand to our new inventory size variable. Or in fact, we can use the old inventory size there to be a bit more precise. So once we've found it, there's no other code that we need to change, so we can break out the for each loop, and that should serve our purpose. It will go through each of these in turn, look for the right opcode with the right value or operand, and then if it finds it, update it and drop out. We can do pretty much the exact same thing for the set slots, or in fact the exact same thing for the set slots. So let's just copy and paste, change the lookup, change the instruction get, and then we're running the same code. I mean, obviously you could optimize this a bit. I'm just doing it for speed and convenience. So that is the bag class updated. We just have another place to look in to get this code all working fine, and that is the player data file. The player data file is your save file. So when you exit the game, it's this file that gets loaded and stores all your information. And if we have a look at, I think it's read. Here we go, the read method. You can see here we've got a hard-coded check to see if the bag is greater than 32 and we want to change that to 64, then trim the array of the bag and assign it. So this would mean that although you could add 64 items into your inventory, as soon as you saved and reloaded, you'd lose anything above the locked 32 level. So we just need to make sure we go through this code and change all these references here, as I'm sure you're familiar with now. First of all, we get the class. So we have a look in the module types first. Player data file. Case sensitive, of course. And then once in there, we need to get the method for read. Again, we know the name. So read, and then get the instructions from the body and instructions. And again, let's have a quick look at the IL. You can see here we're still looking for the same opcode and the same operand, and you can see it's just loaded in 3 times here. So this code that we have run should serve as well. It will go through all the instructions of the read method on the player data file, looking for the integer load of the right size and change it to the new size. There is one thing we need to be aware of though. If we look further down the file, you can see that we're using the same instruction with the same operand elsewhere, but for a different purpose. Here we're looking at the file version, and if it's greater than 32, running some network utils on the player data file. So if we let this code run, in fact, we'd have to get rid of the break. So if we let this code run, what would happen is all the code that we wanted to change would be updated to 64, and that would be brilliant. But then this code down here would never get executed because I don't think there is a version 64 yet. And that's bad because you'll break your save file. So we just need to include a check. There's different ways of doing this. You can look for a specific instruction that you know is happening after you've done all the changes you want, or you can specifically, you could specifically target the line of code that you wanted, although that might break in following versions. So if we have a look here, we know the instruction address of the IL, and we could just target that and update it. But if there was a line added up here in the next version, that would break, so I don't really like doing that. But just for now and simplicity, what we're going to do is add a count variable, and then we know that it's got to update 3 times. 1, 2, 3. So if we say if ++count is equal to 3, then break out the loop. And this way the instructions will load and the code will execute until it's updated 3 versions of it, and then it will just jump out. So that's a quick and dirty way of doing it. You may need to maintain this code later, but you just got to pick your battles sometimes. So let's compile this, which will cause all this to be updated. So if you were doing it in just your normal editor, you'd be at this stage now. Let's compile the mod again. By the way, for this backpack mod, I've already added the XML changes needed to the XUI stuff. Thank you to Stallion's Den, whose XML I've just copied and pasted. I'm not great at XML modding, so that was very much appreciated. There we go. That is compiled now. So one thing to note in SDX7 is it's quite important to start the game through SDX, because it now relies on a command line argument being passed when the game plays. So unless you've manually put that in, things won't work properly. So just make sure you start it through the green play button there. So let's just wait for the game to load. Let's just go into the demo. And while that's loading up, I'll just jump over to the next thing I'm going to quickly show you. Okay, so here we are in the game, and if we press, there we go. So as you can see, the backpack has been extended to 64 items. I'd previously loaded this in and saved it, and now that I've come back into the game, I reloaded my player file. The items are still there, so we know that the XML changes are working. So good stuff. We have altered the vanilla DLL to add new behavior. Let's come out of there. And as a final just quick walkthrough, I'm going to just go through a bit more of a complicated version. When we wanted to import custom entities into SDX, we found we had to alter one of the base methods, or one of the base classes, called Entity Factory, because anytime we passed it a custom class, it would just ignore it because it wasn't part of its internal list. So what we did was track down the class, and then we didn't always know the name, and the name was duplicated with multiple signatures. So rather than just specifying a name, we find the exact method that we want. In fact, let's jump in and find that. So here we go. As you can see, the name is obfuscated. Weirdly enough, it's ZR again, but that will change from build to build. So what we did is we look for the signature types. So parameter count 2, as in it's passing in 2 parameters. The method itself is static, by looking at the static, and that of the 2 parameters, the first one's a game object and the second one's a string. So that way we've narrowed down the exact method that we want to do without having to maintain the code from version to version. And what we've added in is this. So what we've done, I won't go into the detail of it, but basically we have a look to see if the mod class is included in the DLL, and if it is, we just return a version of it. But to get this to work, we had to do a couple of things. We had to find the add component method from Unity Engine. If you've done any Unity work, you'll be very familiar with that method. We needed to find a reference to it. So what I did is I did the quick and dirty version. I searched through all the classes that were available. For all the classes that were available, we searched all the methods, and then we searched through each instruction to find a version of the add component. As soon as we find the thing that we're looking for, we assign a reference to the method reference, and we jump out of the nested for loop. Once we've got what we want, we can use our Entity Factory method to start injecting our own code. and this is done by creating some type references because we are remembering things inside the method. Importing some object references, or importing some method calls. So as you can see in the method, we are doing things like get type calls and object equals, and here all we're doing is finding a reference to that method inside Cecil, so we can use it in our calls down here. So this bit is actually adding the variables that we've created up here into the method, so we can use them later as references. And then we're actually emitting manual IL into the method itself, referencing all the different methods when we need them, like concat and get type. The variables, now that we've injected them up here, and all this is doing is the logic that you can read here in C#. So it takes a little while to get used to all the opcodes and stuff. You can have a look at other examples or build the method you want and have a look at the IL that you need to emit. This method, or sorry, this mod will be available on the forum. Just go to the editor thread. I usually put all my mods at the bottom of the first post. So if you want to do something a bit more advanced and just want to check this code out to see how you do it, feel free. And I think that's pretty much it for this one. Cheers guys, see you later.